Hello, I'm Mr. Parker and this is question 7 on the OCR Core 2 paper from June 2010. For more questions on this exam paper, click the link here. Question 7, part 1. Show that sine squared x minus cos squared x all over 1 minus sine squared x is identical to tan squared x minus 1. There are various ways you can go about proving identities like this. The one that I'm going to use is to start with the left hand side and manipulate it until I get the right hand side. To help with this question, I'm going to write an identity over here which says that sine squared theta plus cos squared theta is always equal to 1. These three lines here mean this is an identity and it's true for every value of theta. So let's start this question by writing out the left hand side. And what I'm going to do first is rewrite 1 minus sine squared x in terms of cos squared x, because if I rearrange this identity up here, I get cos squared theta equals 1 minus sine squared theta. So where I see 1 minus sine squared theta over here, I can replace that by cos squared theta. So the top stays the same. But on the bottom, I now have cos squared x. Next, I'm going to separate this out into two fractions, so I'm going to get sine squared x over cos squared x minus cos squared x over cos squared x. At this point, I need another identity that says that sine theta over cos theta is always equal to tan theta. So remember, sine squared x just means sine x squared. So here I've got sine x over cos x squared, which I can write as tan x squared, or more commonly you write it as tan squared x. Here I've got cos x squared over cos x squared. Well, anything divided by itself is going to give me 1, so I get tan squared x minus 1. Part 2 says, hence solve the equation sine squared x minus cos squared x, all divided by 1 minus sine squared x equals 5 minus tan x. Well, remember in the last part of the question I showed the left hand side here is equal to tan squared x minus 1. So the first thing I'm going to do is rewrite this equation as tan squared x minus 1 equals the right hand side. Now I've got a quadratic involving tan x, and I'm going to rearrange this so that it equals 0. So I get tan squared x. I'm going to add tan x to both sides to remove this term from the right hand side. That becomes plus tan x. And I'm going to subtract 5 from both sides to remove this 5, so I get minus 6. The right hand side now equals 0, and I've got a quadratic in a form that we can solve. This one factorises nicely. I'm looking for two numbers that multiply to give minus 6, and two numbers that add to give 1, because I've just got one lot of tan x. The numbers I want are 3 and minus 2. So I can factorise this quadratic to get tan x plus 3 in one bracket and tan x minus 2 in the other bracket. So for my first set of solutions, I want to make this bracket equal 0, so I get tan x equals minus 3. For the other set of solutions, I want to make this bracket equal 0, and I get tan x equals 2. I'll start by getting all the solutions for this equation here. So to find x, I need to do inverse tan of minus 3. Make sure your calculator is in degrees mode to do this, because we're solving between 0 and 360, and that gives me a solution that says minus 71.5 and so on. However, this solution isn't within my limits of 0 to 360, so this won't be one of my answers. To find some valid solutions using the one we've just found, we need to use the periodic property of the tan graph. Here I've got the tan graph. Hopefully you can see it repeats itself every 180 degrees. So here's my first solution, about minus 71.5, and if I add another 180 I get a second solution here, but this one is within my limits. Look, here's 0, here's 360, and I can also add another 180 and get another solution. So these two solutions here are the ones that I want. So to get my solutions, I'm going to take this one and add 180 to it twice. And the first one is 108 to three significant figures. And the next one is 288 to three significant figures. If I was to add another 180, that would take me past my limit of 360. Now let's deal with the solutions to the second equation. I get x equals inverse tan of 2. And that gives me 63.43 and so on. So my solutions this time are going to be 63.4 to 3 significant figures. And then if I add another 180, I'll get another solution. So I get 243 to 3 significant figures. So my original equation has 4 solutions between 0 and 360.